Okay, next one, let's look at example 4. The displacement of y of a particle varies with time is given by equation here. Where x, okay, again this one shouldn't be x, this should be y. Okay, in this chapter kita gunakan displacement tu, dia punya simbol adalah y, not x. Okay, where y is in cm and t is in second. So kita gunakan unit cm and second. Okay, calculate the frequency of the motion, the velocity of the particle at 2 seconds, the acceleration of a particle at 2 seconds, and then the velocity when the particle is negative 2.5 from the equilibrium position. Okay, first let's look at the equation we are given here. Okay, di mana kita dibagi y sama dengan 4 cos 2 pi t plus pi over 2. Okay, so notice here that now we have cos instead of sin. Okay, so there's no problem with this equation. Just kamu kena notice lah yang sekarang ni kita menggunakan cos bukan sudah sin. Okay, tapi everything else is still the same, di mana this value here is still equal to amplitude. This value here is still equal to omega, and then this one adalah equal to the angle phi. Okay, so first of all, kita mau cari adalah frequency. So we want to find frequency, di mana daripada equation tadi kita dapat omega is 2 pi. And we know that omega formula adalah sama dengan 2 pi f. So f, you can find it's equal to 2 pi divided by 2 pi. So kita dapat frekuensi sama dengan 1 Hz. Next one, we want to find what is the velocity of the particle at 2 seconds. So at 2 seconds, we want to find what is the value for v. So again, this one kita dibagi adalah in terms of y, displacement. In order to find v, we need to differentiate displacement. Okay, so kita kena differentiate displacement. D over dt, displacement kita adalah 4 cos 2 pi t plus pi over 2. Okay, so differentiate senang saja. This one darab dengan this omega. So 4 darab 2 pi, kita akan dapat 8 pi. And then we differentiate cos, akan dapat negative sin. Okay, differentiate cos dapat negative sin, and then the rest you just salin balik saja, 2 pi t plus pi over 2. So this one susun semula, kamu akan dapat negative 8 pi sin 2 pi t plus pi over 2. And then barulah kita substitute the value for 2 seconds here. Second plus pi over 2. So v is equal to negative 25.13 cm per second. Okay, don't forget your calculator must be in radian mode to get this value. Okay, next one, we want to find what is the acceleration at 2 seconds. So next one, kita mau cari what is the acceleration. So in order to find acceleration, kita kena differentiate the velocity. Okay, velocity yang mana? Yang tadi kita dapat, which is this one. So this is the new equation untuk velocity. So we differentiate here. Kita differentiate d over dt. Velocity negative 8 pi sin 2 pi t plus pi over 2. Okay, differentiate this whole thing darab dengan omega. So negative 8 pi darab dengan 2 pi, kita akan dapat negative 16 pi square. And then differentiate sin, kita akan dapat cos. The rest you just salin balik sahaja. Okay, so this is a new equation for acceleration, and then kita substitute the value for t is equal to 2 seconds. Okay, so we masukkan, just substitute macam biasa sahaja. and then tekan calculator, you will get the acceleration is at equal to 0 centimeter per second squared. And last one, we want to find what is the velocity when the particle is 2.5 cm from equilibrium point. So we want to find, okay, last question, soalan D. What is V when y is equal to negative 2.5 cm? So kita gunakan formula yang sama macam the previous example. V is equal to plus minus omega a square minus y square. So you just substitute all of the value. We have omega is 2 pi daripada sini tadi. Amplitude is 4 cm minus 2.5 negative 2.5 square. So dapat V is equal to 19.62 cm per second.